Today we'll talk about Lewis dot structure or the octet rule. And this is one of the theories trying to explain the covalent bond. So let's start. First one was octet rule. This for Kossel and Lewis approach to chemical bond. Kossel and Lewis. And later became Lewis structure. What is octet rule? This is a rule for tendency of an atom to have 8 electron in valence shell to be complete, like nearest noble gas. So, low tendency of atoms to have 8 electron in valence shell. يعني meaning atoms gain or lose or share electron to fill the outermost energy shell with 8 electron to be the nearest noble gas, the most stable type. All atoms? No, except hydrogen, lithium, beryllium. Why? Of course, we know hydrogen just have 1 electron. Lithium, atomic number 3, so its external outermost have 1. Beryllium, it's complete 2 already. Has 4 atomic number and has 2. So only those 3, hydrogen, lithium, beryllium, these are seeking to اللي هو الدوبلت condition بقى, not octet. As what? As helium. Okay? Done. Right, let's see how we can apply this one. First of all, hydrogen, water. Okay. What is the rule to do Lewis structure? First thing we have to, there is steps. If you follow it, it will be too much easy. So if you follow the steps, number one, we will count all the valence, electron valence. So valence electron here is what? This is hydrogen, of course, 1. So 2 by 1 plus oxygen in group 6A. Anyway, oxygen 8 to 6. So it has 6 electron in outermost. This is called valence electron. Okay, and also it's in group 6A. So if I don't know that, so I can 6A, so she has external 6 electron. So 6. This is the total 1. So total 8 electron. 2 by 1 plus 6, 2. So 8 electron. Okay, طيب. Next step, I have to determine which one is the central atom. Central atom, of course, here will be oxygen. Okay, and it has the least number of atoms in the compound. Also, the lowest electronegativity, also the highest oxidation number. So central atom, there's 3 ways to detect it. Easy. So right now, I determine which one is the central atom. It's the oxygen. طيب, oxygen is a central atom. I have to put the other atom around and make lines. Lines, it's called bond. Each one has, of course, here one electron, here one electron. This is meaning two electron already. So I have to deduct those electron from the total number of electrons. So here we consume 4 electrons. So minus 4, remaining 4 electron. This 4 electron, we should put it for the external atoms first to complete it. But we told there is exception for hydrogen. It's already completed. She has 2 already, so done. So what I'll do with this 4 electron, I'll put here 1, 2, 3, 4. So this is the Lewis structure for water. Done. طيب, what else? We can do it same, easy, for ammonia, NH3. Of course, nitrogen is group 5A. So external, she has 5 electrons. So 5 plus hydrogen 3 atom by 1. So total also 8 electron. Total 8 electron. Type. If I want to write, and of course, list number for nitrogen, so it's the central atom. Done. So I'll do it. So H, hydrogen. Type. How many electron I consumed here? This one, 2 electron. And here 2, and here 2. خلاص? This is bond pair. So I consume 6 electron. So minus 6, remaining 2 electron. Where I'll put, of course, this is done already. Hydrogen all done. So this one here and here. تمام. And this is stable. طيب. Let's see other structures. I'll say مثلا CO2, carbon dioxide. Carbon dioxide. Okay. Carbon. Carb 6, 2, 4. She has 4 valence electrons. What about oxygen? We said oxygen group 6A, 6 electron. If you don't know a periodic table, so make it like this, 2, 6. So she has 6 electron outside. So calculate the total number of valence electron for carbon 4 plus 2 by 6 for oxygen. So 12 plus 4, it's total 16 electron. تمام. So which one is the central atom? Carbon. Okay, so we have to make one bond to the other atom. Okay, here, how many we consume? 4 electron. Done. So minus 4. So remaining 12 electron. Here بقى 12 electron. I start to complete the octet for the oxygen, the external atom. I have to complete the octet for this. Here we have 2. So I have to put 1, 2, 3, 4, 5, 6. Okay, so right now she has 8 already. 2, 4, 6, 8. Around 8, 8. So it's full octet. So for this one, 1, 1, 2, 3, 4, 5, 6. So right now I finished already the electron. So here 6 and here 6. So 12 the remaining done. Right now, is this stable? No. Why? Look. Here carbon dioxide don't have any charge on it. Okay? But here, there is a charge. How you know? Yes. Listen, there is rule. We have to count. It's called the formal charge. Formal charge here is what? اللي هو total number of electron. I have total for oxygen is 6 electron. Valence electron 6. But how many how many electron around it? I have 2, 4, 6, and the one for it, not the 2, just one of it. So total 7 around the oxygen. So it's formal charge 6 minus 7 equal minus 1. Meaning oxygen have minus 1. Oh, this is minus 1. Now, of course, this is same exactly, so it has minus 1. Now, what about carbon? Again, for carbon, formal charge for carbon equal total number of valence electron 4 minus the electrons around it. Of course, she has just one here and one here. خلاص? 1 and 1. Type 4 minus 2. So total equal positive 2. So the oxygen now have positive 2. Listen carefully because this is a very important point. Now we have for carbon 2, positive 2, and oxygen minus 1, minus 1. Yes, in total, minus 1, positive 2, all neutral. But this is not the most stable condition for this compound. So what we will do? I have to take, remove this one. I have to take 2 electrons from this oxygen. Done, and I'll put 1 bond here. In this moment, what happened? Of course, remove this charge also. In this moment, what happened? If I need to see the formal charge for carbon, for oxygen here, how much? It's 6 minus 1, 2, 3, 4, 5, 6. So 6 minus 6 became 0. So oxygen here became 0 charge. Stable. Now what about carbon? It's 1, 2, 3. So the carbon here is what? Formal charge for it. 4 minus 3 electron around, so positive 1. So still it positive 1. What is the most stable condition? If I have minus 1 here and positive 1 here, so in general it is 0, or every one of the atoms 0 charge, 0, 0, 0. Of course, to be all 0, 0, 0 is the most stable. So the carbon dioxide at the end, it will be like this. Carbon, O, 1, 2, 1, 2. And here, O, 1, 2, 1, 2. Up here, any charge? There is no charge. So this is the most stable Lewis structure for carbon dioxide. Done? I'll give you more example. But first, let us read the steps. Now I explained it many times, but we need to read it. And if you want to keep it for you. So step to draw Lewis dot structure. First, find the total number of valence electrons. We found it. Determine the center atom. Type. It's someone tell I don't know what is the center type. It's the least number of atom. Or it has the least electronegativity, or has the highest oxidation number inside the compound. But remember, don't tell me hydrogen is central atom. Always hydrogen outside, because it's just one electron. Done? Okay. I'll draw single bond to the central atom. Done? I'll deduct step 3 from step 1. So to get the lone pair electron or the remaining electron. But after that, I'll use this remaining valence electron to complete the octet on outside atoms first, as I start with oxygen, not the carbon. So start from outside first, then the inside. After, count formal charge, as I show you. How to count the formal charge? Valence electron minus electron surrounding it. So you can get the partial charge on each atom in the compound. After that, what I'll do? خلاص. Check if the main compound the giving there is charge or no, positive, negative, or neutral. So according to that, you will handle the situation. This is the easy way to write Lewis dot structure. There is almost 4 types to yani 4 methods, but this is the most fulfill and simple and accurate one. Done? طيب. I'll take other examples. يعني مثلا I'll write what ozone, okay, O3 ozone. Of course there is only one type ozone. Oxygen is group 6A as I thought, so have 6 electron, so total electron 3 by 6, 18 electron. So what is the central atom? Of course all oxygen. So oxygen, 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 and we will make one bond between the central and those. Done? Right. How many electron I consumed here? Here 2. This is bond pair called. So 2 electron, so I consumed 4. So minus 4, 18 minus 4, 14 electron remaining. Time. Those 14 electron, what I'll do, I have to start from outside. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I consume 6 and 6, so 12. So remaining 2, I'll put inside. So now I consume all the valence electron. But is this stable? Let's see. Formal charge for the external oxygens. Here I have 6 minus. Just to see where it is. 1, 2, 3, 4, 5, 6, and here is just 7. Only this one. خلاص. So 6 minus 7 equal minus 1. So it has minus 1 here and minus 1 here. But what about the one in center? Formal charge. هنقول 6 minus how many electrons she has? Look, 1, 2. Those 2. And here 3 and here 4. Only those around it. 6 minus 4 equal 2. So oxygen here have plus 2. Right. Right now, yes, here 0 charge. This compound molecule or atom has no charge here. So here minus 1 plus 2. Yes, it's neutral, but it's not the most stable. So what I'll do, this is minus 1. So I'll consume 2 electrons from this to make one bond here. Let's see how it will go. I'll put this. So if I need to check now formal charge, it's 6 minus 6, 0. So this is 0. Done? Type. And here, remove this one. Now check how many. 6 minus 1, 2, 3, 4, 5. So this is positive 1 right now. So positive minus. That's okay, acceptable. And this one could be like this: oxygen, oxygen, oxygen. And here it will be like this: 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay. And this is positive 1 minus 1, 0. That is called what? Look, I make the arrow two-way. So meaning resonance. يعني structure here, this one break, and the new found here. So it's called resonance. Resonance. Then it's like frequency. Tac, tac. So this correct and that correct. So this is for ozone. Let's see other one. I like to do NO3 minus. 1. Nitrate. Here it has charge already. So I'll do what? Of course, nitrogen, it's 7. So 2, 5. Or it's group 5A. So have 5 electron. Valence electron for it. Oxygen, خلاص, we remember it. 6. So it's 3 by 6. Done? No, there is 1 electron here. Should be you write plus 1. Because it's added to the valence electron already. So 18 plus 5, 23. And 1, 24 electron now. Type. Where is the central atom? Of course, nitrogen. Nitrogen central atom. Done? And write 1 bond to each atom. Done. How many we consume here? Of course, 6. 2, 2, 2. So I consume 6. Later is 18 electron remaining. 18, I have to put it from outside to inside. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Done? Yes. I consume already the 18 electron. So is this stable? We'll see from the formal charge. So 6 minus 7, this is minus 1. I will not repeat by what I did before. So here minus 1, and here minus 1, here minus 1. But what about here? It's 5 minus 3 equal positive 2. So this is positive 2. But here is just minus 1 only. So if you look to it here, if you take the compound from here like this, all this neutral and here minus 1, so everything is okay. Yes, but it's not the most stable one. If I can reduce the charges around the compound, meaning I am going to the stable form. So better reduce the charge later. Type. How we will reduce the charge? Here, I have to remove from here 1. I remove those. I have to remove this and I'll make it like that. 1, 2, 1, 2. Yes. And that one, it will be here. Done. So in this moment, the charge will change. So here 2, 4, 6, 8. So it's full here. Octet is full. So we are following Lewis structure. Type. Done? I'm just showing you. So Here, how many electron around? There is 1, 2, 3, 4. So I said 5, so it is positive 1. So I leave, look. Now, mhm. Now positive 1 minus 1, it's equal 0. And here minus 1, so I am okay because the structure was like this. So this is the most stable form or structure. Type. In this moment, I can, right now, I can do like this. In general, I'm telling it's total charge minus 1. Type. This electron have resonance? Of course have resonance. Why? Because this bond could break and it created here. So it will rotate. One bond here, break. One bond forming here, break. One bond forming here. So it's like tick, 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 tick. That is called resonance. Done? Okay. طيب, what else? I think it's very simple. Right now, let's save this one. I'll give one brilliant question to see it is. Type. Which compound has a resonance structure according to Lewis dot? Sulfur trioxide, this one without any charge, take care. And this is sulfite anion or a sulfite radical type. Here there is a charge. Which one of those has a resonance structure? I think you have to answer it alone. Try to answer and see my answer. طب I'll start with SO3 sulfur trioxide. تمام. Quickly بقى. طبعا sulfur is same as oxygen in same group. Both group 6A. Both group 6A. So it's 6A. So here 6 plus 3 and 6. No charge. So done. 24 electron. Very good. طيب. Here the sulfur is the center. Okay. And here the, and here the, and here the. Oxygen, oxygen, oxygen. Very good. Show me where is, how many we consume here? 2, 2, 2. So I consume 6. So remaining is 18 electron. By 18 distributed. Just a second. Yeah. To see what to do. I'll distribute 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Done. Type. Here, from my sides, this is equal minus 1 right now. And this is minus 1, and this is minus 1. What about sulfur? It's 6 valence electron minus 3 surrounding it. Show you. There is one here, one here, one here for sulfur. So 6 minus 3, it's positive 3. So it's positive times 3. Okay. Right. The question is this stable right now? Is this have resonance? Let's see. Right. This is minus 1. So I'll remove it and put 1. I'll put 1 here. True. But when I remove, I have to correct the position of this electron. I'll put it like this, like this. That's correct. So this is 0 right now, charge. And here became positive 2. What else? No, you need to reach it. It's neutral, full neutral. So I'll do what? I'll do this and cut this one. Oxygen. 1, 2, 1, 2. Here, 1. Here. Remove this one and remove this one. It will be like this. Also, this one. So this is the most stable structure for sulfur trioxide. And hence it has no resonance. This one has no resonance. Why no resonance? Because it's all same. If I change it like this, right or left, it will be same. Type. The answer meaning sulfite has resonance, but let's see. SO3, 2 minus. Done. Done. I'll answer quickly. Sulfite. So it's also same. 6 plus 3 by 6. Plus 2 electron. So here 6 by 18, 24, 26 electron. So where are you? I'm here. Sulfur. 1. 1. So O, O, O. Let's work right now. How many I consume here? 6. So minus 6. So 20 remaining. Lone pair. So 20. Where? How you will put it? I'll put 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I consume 18. There is 2. 1, 2. خلاص؟ Hallelujah. طب what here بقى? This is here 6 electron minus 7, so minus 1, minus 1, minus 1. But what about sulfur? Sulfur, right now it's 6 minus 1, 2, 3, 4, 5. I'm showing you where I'm count. 1, 2, 3, 4, 5. So it's containing positive 1. طيب here in general total I have minus 2. Huh? So what you have to do? Yes, this minus 1, positive 1, deleted. So if these two charge delete each other, يعني like this, if these two charges, so the total charge will be minus 1, minus 1, minus 2, it's correct. So what I'll do to delete this two charge? What to do to delete this charge? Of course, I'll remove the electrons, but not all, and just to correct the position, I'll be like, it will be here. So I remove that charge, both one, like this. Good. Right. In this case, remove this charge, because here, now the sulfur became neutral. One electron, one electron, one electron. So 1, 2, 3, 4, 5, 6. So 6 minus 6 equals 0. So the charge here on sulfur became 0. A charge here, 0. So I delete the two charge. So here minus 1 and here minus 1. Very nice. Done? Right. In this case, I can make like this, minus 2 up. But this has resonance? Yeah, of course, because the structure could be like this. S. Could be the charge here, and here oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And this is the 1, 2, 3, 4. If you count, look here. octet. Why? 1, 2, 3, 4, 5, 6, 7, 8. Octet. طب what about sulfur? 1, 2, 3, 4, 5, 6, 7, 8. Octet. Oxygen, octet. Everything is octet right now. Done? Hmm. Hmm. Done? So here I am writing -2. So it's resonance. Look the structure from here to here, and it could be here also. So 3 resonance. Tack, tack, tack. See? And for final one, I'll tell you the steps. I'll show it to you again. Just this is Lewis structure. Clear and simple. Thank you.